Lesson 12, Relative Motion. All right, so in lessons 10 and 11, we talked about vectors and adding vectors and breaking vectors into their components, their x and y components. Now, kind of where we're headed, just to give you an idea, is going to be, let's say that you had a vector, you're walking this way. So then you're walking this way, the velocity of 2 meters per second. But then you also have the wind at your back. So now we're going to add the velocity of the wind at your back at, 4 meters per second. And it's going to say, okay, what's your total speed? And I guess that should be on a boat or something because the wind's probably not going to affect you if you're walking. But let's say you're on a boat going 2 meters per second. So that's kind of the general idea of where we're headed here. Okay, but first we're going to talk about relative motion and frames of reference. So you guys can go ahead and read this paragraph here. But what the general idea here is that in order to actually talk coherently about, let's say, how fast something is going, you always have to ask the question, yeah, but relative to what? And what I mean by that, and I think an easy way to kind of help people understand this, which is kind of a cool idea too, is that if I was to ask you, okay, how fast are you moving right now? And you might say, well, Mr. Brown, that's pretty easy. I'm moving 0 meters per second or kilometers an hour or whatever it might be. And I'd be like, okay, yeah, that could be true. But what if I said, yeah, but if you think about the Earth rotating, well, actually we're moving incredibly fast because of the speed of the Earth rotating. We're moving at like way faster than a jet airliner. So you are moving right now. You're moving really fast. And I said, okay, well, now we got two speeds. It could either be 0 or that. But then I could say, yeah, but the Earth is revolving around the sun, and you're going even faster than that now. So if we talk about relative to the sun, now we're moving even faster. And then again, I could say, okay, and the sun is revolving around the center of a black hole in our galaxy. And we're moving even faster now. So you're revolving again even faster than you were. And then if you think about it again, we could say, okay, well, the universe is actually expanding, and it's accelerating even. So depending on where you look at it, we're actually going an infinite amount of speeds. You could say we're moving 0 kilometers an hour, or you could say we're moving at the speed of light if you were comparing it to the right thing. So it really does matter on what you compare your speed to. So that's what you kind of mean by relative motion or frames of reference. It's all relative to what? All right, so if we look at example number 1 here, it says a car, a unicyclist, and a jogger are moving past a person standing on the ground. The car is moving east at 20 meters per second relative to the ground. The unicyclist is moving east at 10 meters per second relative to the ground. And the jogger is running east at 5 meters per second relative to the ground. What are the relative velocities of the other people relative to the person standing still, the jogger, the unicyclist, and the car driver? So I've made a little chart here. So now we're saying, so the first one here is relative to the person standing still, what's the speed of the car? And I've kind of drawn a little picture here to make this, hopefully this makes sense. So there's my person standing still is the one up top, and the car below, my awesome picture of a unicyclist, and my person running. Okay, so this one's pretty straightforward because we're just comparing it to that thing standing still, the person standing still, right? I guess I shouldn't call him a thing. Okay, so if you look at the car, relative to the person standing still, the car is going to be going 20 meters per second, and the arrow is going to the east, right? So just like normal, because it's comparing it to that person. Same with the unicyclist, same with the person running. So we can see that the car is 20, 10, and 5, and relative to the person standing still, relative to himself, really, he's going 0. Now, if we say relative to the jogger, so the jogger down here, right, this 5 meters per second, what we're saying is that it's like you put your finger on that jogger, and we're saying, okay, that person's not going to move. We're going to call that 0 meters per second. So if I could put my finger on that person and say, okay, that is now our new 0, then think about this jogger as it was running away from you. And let's say, again, that you couldn't see the ground, though. So you were in outer space, let's say. This, I always find this helpful. If you were in outer space and this person is moving away from you at 5 meters per second, well, you wouldn't know if the person was moving away from you or whether you were moving away from the person. So that person standing still now, the person who was standing still to begin with, if you compare him to the person running, now he just appears that he is just moving backwards. He's moving now the opposite direction. So our person that was standing still, he is going to be now going 5 meters per second the other way. He's going to the west now. He's seeing himself moving backwards, right? So relative to that person jogging. If we think about, let's say, the jogger, well, relative to himself, he's going to be going 0, right? We're calling that 0. Now the unicyclist, if we think about, okay, if the person jogging is 0, then the unicyclist is still going to appear like he's moving forward only at 5 meters per second now, but moving to the east. So not 10 meters per second anymore. Relative to that person jogging, he's only going 5 meters per second to the east. The car is now going 15 meters per second to the east. Okay, relative to the unicyclist. So now what we're going to do is think about, okay, now the unicyclist over here, we're going to put our finger on him and say, okay, now he isn't moving. He's going 0 meters per second. What's everything else going relative to that? So if we look at that, let's compare him to the person here now. So, or the jogger, I mean. So the jogger now, if you could think about this jogger and the unicyclist in outer space, so you couldn't see anything but the two of them, from the perspective of the jogger, it looks like he's just going to be moving backwards at 5 meters per second now, right? I can't tell if that jogger or the unicyclist is moving away from me or whether I'm moving away from him. And if we're calling the unicyclist 0, then I'm saying I'm moving away from him at 5 meters per second. So I'm not going to go through the rest of them. They're all kind of the same idea there. Hopefully you can kind of make sense of this table that I've made. Or I guess that I've made, Mr. Light made. Yeah, so let's move on to relative motion, winds, and current. And I'll actually end that video there just for the sake of time.